In this video, we're going to look at comparing the size of decimal numbers and putting them in order. So this first example says, put these numbers in order from greatest to least. The first thing I want to do is line them up, just like we did with the large numbers in the last section, making sure the place values are all in the right column. So I'm going to start by lining up the decimals. So you can see I've been careful to make sure my decimals are all aligned. Then I know my tenths are aligned, my ones, and my tens. Now it's really easy for me to compare these. The biggest one, remember when we're comparing and we have them lined up, we can start from the left because we know that the 50s is bigger than a 2. So this is the smallest one. So I can go ahead and write that kind of at the end of my list here, 27.5. Then I'm like, okay, these two are the same, but and looking at the ones, the 7 is clearly bigger than the 2. So that must be the biggest one, 57.2. And then the 52.7 is in the middle. Really, you could have looked at this and said very easily, 57 is bigger than 52 is bigger than 27. They've added these decimal numbers on the end to try and confuse you. But really, if the whole numbers are significantly different, you don't even have to look at the decimal numbers. Whole numbers are bigger. Think dollars and cents. $57 is obviously bigger than $52, which is bigger than $27. Doesn't matter if you have 75 cents, 95 cents with any of those, $57 is always bigger than $52, no matter this part here. Okay, so this question, or this example rather, says, put these numbers in order from least to greatest. Same kind of idea. Be careful, they mix those words up to confuse us sometimes. I found this one a little tricky to look at because there's so many 7s. So my first step was to line them up. And really that makes it pretty straightforward. Obviously this is the biggest one. Then it gets a little trickier though. Because okay, this is a 7, 0, 0. Those ones seem the same in the whole column. In the tenths, they're the same. But then there's nothing here in the hundreds to compare. So over here, I thought, you know what will make it easier for us to look at? Think of it as a price. We're used to seeing prices. $7.77, 77 cents. And with this 0.7 or 7 tenths, yes, we can add that imaginary 0. We talked about this before, and I thought I'd just show you a couple pictures to really illustrate that fact. If we just want to say 7 tenths, 0.7, this is what 7 tenths looks like, right? We have 10 pieces and 7 are colored in. If we want to add that imaginary 0, now we're reading this as 0 and 70 hundredths. Remember, we read the name where the number ends. So this is 70 colored in out of 100 pieces. If you look at the two shapes, think of that as the whole. The same amount of this bright blue is in both shapes. We've just drawn many, many more parts. But this is really fraction related. But if you think of this as a long pizza, if you ask for 7 tenths of the pizza or 70 hundredths of the pizza, you're getting the same amount. So yes, I could put another 0 on there if I wanted, and I could split this whole into 1,000 pieces and color in 700 of them, and there'd still be that same amount of blue. It would still be the same number. So that's why we can add that imaginary 0 there. Something to be aware of is we cannot add an imaginary 0 between the decimal and the 7, because now we're changing it from 70 cents to 7 cents, which we know is a different number. This will come up again, and I'm hoping I'll have a chance to explain it to you in class as well. But now that we have those three written as prices, something we're more familiar with, I think it's obvious to see that the smallest one is 70 cents, 0.7, or 0 and 70 hundredths, or 0 and 7 tenths, however you want to say it, followed by 77 cents, or 0 and 77 hundredths, followed by the biggest one being $7.77, or 7 whole and 77 hundredths. In this example, they want us to identify which sign makes the statement true. 604 and 9 tenths versus 623 and 8 tenths. Probably just by looking at this, you can tell this is the bigger number. But again, I've lined them up, starting by lining up my decimals and then carefully keeping my tenths in the same column, my ones, my tens, and my hundreds. I'm going to start by looking at my hundreds. Same. Oh, I look in the tens. 23 is obviously, or 20, obviously bigger than 0. 2 bigger than 0. So this one, as we said, is the bigger one. So we're going to write this one, which is this one. 604 and 9/10 is smaller than 623 and 8/10. So this example reminds me of what we were talking about just a minute ago with those sort of imaginary zeros that we can and cannot add. So this one says, which sign makes the statement true? 972 and 640 thousandths versus 972 and 64 hundredths. So when we look, again, I've lined them up carefully. Yep, hundreds are the same, tens are the same, twos are the same, tenths are the same, hundredths are the same. This one has a 0 in the thousands and this one has nothing. Well, keep in mind, as we said before, if it's after the last sort of digit here, we can add another 0. It's just we can't put a 0 between any of the digits or between the decimal and a digit. Because if I put a 0 here, I'd be bumping that 4 into the thousands column. If I put a 0 here, I'd be bumping both those numbers over to the right. But if I'm just adding this invisible 0 on the end, I could add as many as I want. It doesn't change the number value of, really, there's just 64 hundredths in both questions. So this is equal. That's it for this video. Good luck with this section.